Well, good morning there, math ninjas. Yes, you can be ninjas this time. We're going to be working today on adding and subtracting integers. We've already covered multiplying integers and dividing integers. Today, we're going to just get started with this concept, and we're going to work on modeling adding and subtracting integers with the counters and number lines. Materials you will need for this video are your pencil, a ruler, Notes 1, which is your integer rules notes, and Note 0, which is your Unit 1 vocabulary. Let's start briefly with some vocabulary words. A word you're going to hear a lot today is opposite or additive inverse. Those are synonyms. So the additive inverse of a number is its opposite. Opposite numbers have different signs, and when combined become 0. So if you look at the example, the opposite of 2 is -2. The additive inverse of -3 is 3. Other words you may have heard before, but I still want you to write them down. Sum is the result of an addition problem, and difference is the result of a subtraction problem. Pause the video now and write down these 3 vocabulary words definitions and examples on your Note 0. Now let's go to Notes 1. This is the second page of Notes 1, so that's where you should be. So we're going to start by using number lines to add and subtract integers. So the instructions here say label the number line with numbers 1 through 6 and -1 through -6. So let's start with that. All right. So for each of these 3 problems, A, B, and C, I'm going to use different colors. So if you'd like to use different colors, you may, but you're not required to. So numbers are attached to the signs in front of them. So if we take a look at the expression on A, -1 minus 4, that 1 owns that negative sign in front of it. So the 1 is negative, and that 4 owns that negative sign in front of it. Yes, it's a subtraction sign, but it is also the sign for the 4. So the way we're going to model this is the following. We're going to start at 0. And our first integer tells us to go 1 in the negative direction. So we go 1 in the negative direction. Then the next integer says -4, which means to go 4 more spaces in the negative direction. So we start at -1, 1, 2, 3, 4. And where do we end up? -5. So -1 minus 4 is -5. Let's try this again. On B, what's the sign on the 3? Well, the 3 owns the sign in front of it, so the 3 is negative. What's the sign on the 7? The 7 owns the sign in front of it. Yes, it's a plus sign, but that 7 owns the sign. So here we go. We're going to start at 0 again, and we go 3 in the negative direction. 1, 2, 3. And now we have to go 7 in the positive direction. It's a little squished here, so I'm going to come up here in green. 1, 2, 3, 4, 5, 6, 7. So plus 7. And where do we end up? 4. So -3 plus 7 is positive 4. One more example. Let's try together. C. What's the sign on the 2? Well, the 2 doesn't have any sign in front of it, so we assume it to be a positive. What's the sign on the 5? The 5 owns the sign in front of it, so the 5 is negative. So we're going to start at 0, and we're going to go 2 units in the positive direction. 1, 2. And now we need to go 5 units in the negative direction. So right now we're at +2, so that's where we're starting. 1, 2, 3, 4, 5. And if we look to see where we are on our number line, we're at -3. So +2 minus 5 is -3. Let's work on this a little bit more. So A, again, what's the sign on the 4? It owns the sign in front of it, so the 4 is negative. What's the sign on the 2? Whoops. So the 2 is positive. Take your ruler and draw yourself a number line. We know we're going to be going both in the positive and negative direction. So let's get enough integers on our number line so that we'll be able to demonstrate this accurately. Okay, so where are we going to start? Well, again, we start always at 0. This problem tells us to move 4 units in the negative direction and then 2 units in the positive direction. So if I look and see where we end up at -2. Now we can also model this using counters. So let's take a look at what that looks like. We said we have 4 negative counters, 1, 2, 3, 4. And we have 2 positive counters, 1, 2. Do you see any opposites or additive inverse pairs here? Well, 1 positive and 1 negative is an additive inverse pair, and they equal 0 when you combine them. And there's another additive inverse pair. They equal 0 when you combine them. So if we look to see what is left, we have 2 counters left, and they're negative. So -2. Let's try again. B, what's the sign on the 1? Well, there's no sign in front of it, so we assume it to be positive. What's the sign on the 6? Remember, that 6 owns that sign in front of it. So the 6 is negative. Very good. So let's draw our number line. I might move 0 a little bit further to the right, so I'll have space to go in the negative direction. So where do we start? 0, that's right. And where do we go first? 1, what direction? To the right, because it's positive. Then where? Sorry about that. 6 more units in the negative direction. So 1, 2, 3, 4, 5, and 6. Where did we end up? -5. Let's demonstrate that with some counters. So we have 1 positive counter. And how many negative counters? 6. 1, 2, 3, 4, 5, 6. How many additive inverse pairs do you see? Did you say 1? You'd be right. So what's left? 5 negative counters, which is what we got on the number line as well. Now on examples C and D, we encounter something that I call a double sign. You see 2 signs touching each other with no number in between. So what that really means, this negative sign right here is really a -1. So that -1 is being multiplied by the -4. So we, according to order of operations, have to do that multiplication first. So we're going to pretend that that -3 isn't there, and we're going to deal with the multiplication first. Well, what's -1 times -4? It's positive 4. So now we have simplified the double sign. So now it's time to bring down the other integer. And once we've done that, we're ready to go again. What's the sign on the 3? You got it, it's negative. What's the sign on the 4? The 4 now owns this sign that we've simplified. So the 4 is positive. So let's get integers on our number line. Where do we start? At 0, that's right. Where do we go first? 3 in the negative direction. 1, 2, 3. And then where? That's right, 4 in the positive direction. 1, 2, 3, 4. If we look to see where we end up at 1. When we're demonstrating the counters, we're going to use our simplified expression. So we have 3 negative counters, 1, 2, 3, 4 positive counters, 1, 2, 3, 4. How many additive inverse pairs do you see? Did you say 3? 1, 2, 3. You'd be right, leaving us just with 1 positive counter. And here's our final example. Again, we have this double sign in the middle where we have a positive sign, then parentheses, and then a -5. Remember, whenever we have that double sign, this is really a -1. Sorry, a +1 this time. And so that's +1 times -5 that we have to simplify first according to order of operation. So we're going to pretend this term is not here. What is +1 times -5? Well, a positive times a negative is a negative, and 1 times 5 is 5. Then we bring down the other term, and we're ready to go here. What's the sign on the first 5? It's negative. What's the sign on the second 5? It owns the sign in front of it, so it's also negative. So as we can see, we're going to go in the negative direction a lot. So this time, I'm going to opt to put 0 on the right, so I have room for all of my integers that I'm going to be demonstrating as negatives. Okay, where do we start? 0. You've got it. Where do we go first? 5 units in the negative direction. 1, 2, 3, 4, 5. Now where? 5 more units in the negative direction. 1, 2, 3, 4, 5. Where'd we end up? -10. With the counters, we first have 5 negative counters. And then we have 5 more negative counters. How many additive inverse pairs do you think we have here? Did you say 5? That's not right. We have to have a positive and a negative. They have to be opposites to be additive inverses. I don't see any positives, so we don't have any additive inverse pairs, which means we cannot cancel anything out, and what we're left with is our sum. How many negative counters are here? 10, and they're negative. So here we have it. After watching this video and completing the notes together, please complete the worksheet below on your own. You should have a printed copy of this. Use a ruler when drawing your number lines. Pay attention because some problems are addition and subtraction while others are multiplication or division. We'll go over this in class tomorrow, and it's part of your homework assignment. This is the assignment. You should have a printed copy of it. If you do not have a printed copy of it, do it on your own sheet of paper and be sure to use a ruler. See you next time.